In the previous video, we calculated the mean of this frequency distribution that we have over here on the left in blue. And now what I want to do here is pick up where we left off and now use that mean to calculate the standard deviation of the frequency distribution. And so what we first notice when we look at this formula for the standard deviation of the frequency distribution is that this formula contains the mean. So the mean is part of the calculation. So right here you see an x bar in the formula for the standard deviation, and this is the x bar. The estimated mean, that's our x bar from the frequency distribution. So that, well, it's rounded to 4 places, but 2.6707. That's going to be what we use in this formula. So let's look at the formula. We already have our x values. Remember, these are our estimated x values. So the x in the formula, that's going to be those numbers. All right, so now let's look at the formula and what it's telling us to do. There's very multiple steps here, and just like with the mean, there's no easy one-step way to do this in Excel because Excel doesn't work very fluidly or very easily with estimations. And this is an estimation. So in this formula, if you look at the numerator of the fraction, we're going to have to first find x minus the mean for each x value. That's x minus x bar. And we're going to have to square that value. So we're going to have to do x minus x bar quantity squared. And so let's do that in column F. So up here I'll write x minus x bar squared. So that's, we'll get those values in column F. And then multiply each one of those by the corresponding frequency. So multiply each by f. Okay, so that'll be up to there. Then we're going to have to add those up, find the sum. Okay, so step 1, it looks like we're going to do it this way. X minus x bar squared. And once we have those, then we can multiply by f. So that'll get us out to here. And once we multiply each one of those 6 values by f, then we can add them up. And so that's the summation here. So now those 3 steps will take care of the numerator of that fraction. Then we're going to have to divide that by n minus 1. Okay, so once we divide by n minus 1, now we're here. And then finally, the last thing to do is take the square root. And that will give us the entire calculation that we need. So we have to do this in stages or in steps. Because like I said, this is not a one-step process because it's an estimation. Okay, so let's start this process and see what we can do on Excel. This is one way to do this problem. Now you could combine steps or you could split it up into multiple steps. I'm doing it in a way that makes sense to me. Not too much at one time, but not breaking it up into too many steps. So first thing I'm doing is this, and I'll circle this in red, or I'll put a box around this in red. So that's the current step, and we're putting this in column F. So we have, let's see, we have our x value in column D, and we have our mean down here in location C13. So we want to take each x value one by one and subtract the mean one by one. And then we need that quantity squared. So I'll keep a box around this because we're going to be using that X bar or that mean of the frequency distribution. Now, there's one sort of new function on Excel that I'm going to be introducing, and it's a pretty important one in the context of this problem. Okay, so, and it'll come in just a couple of moments. So I'm just going to type in exactly what I've written in red, equal parenthesis, take the X value, which is right here in D3, X value, minus the mean, which is C13, close those parentheses, and then square it. So D3 minus C13. D3 is the X value, C13 is the mean, subtract those two numbers, and then square it. Okay, now, okay, sorry, there we go. There was a issue with the format of the number, so I just had to switch it back to general. Okay, so now we have X minus the mean quantity squared, and we want to repeat this process down here. But what did I just type there? What did I just type? So let's bring an arrow down here. So I just typed an equal sign, then parenthesis, then the X value, which was D3. That's the 2.445. And then I subtracted the mean, which was C13, and then I raised that to the second power. That's X minus X bar squared. Now, when I drag this down, when I hover my mouse cursor over the bottom right-hand corner of that cell and drag this down so Excel could repeat those calculations 5 more times, what happens? Well, the D3 changes to a D4, which is what we want, because that's the next X value in D4. But the C13 changes to C14. And then when I drag it down to the next cell, the D4 becomes a D5, and the C14 becomes a C15. And so on. So this is good. That's the first X value. That's the second X value. That's the third X value. That's what Excel normally does, and that's what we want to happen. But the problem is C14 is this empty cell, and C15 is this empty cell. We don't want that C13 to change. For all 6 of these calculations, we want C13 to remain C13. Okay, so the way we do this on Excel is insert a $sign before the index, or before the number, the thing you want to freeze. So we want to freeze that C13 and always use C13. So between the C and the 13, we'll have to type in a $sign. And what that does is anything after the $sign is frozen. It's not going to change. So now with the $sign there, when I drag this formula down, the D3 becomes a D4. But the C13 remains C13. And then the D4 becomes a D5. But the C13 remains C13. So in every, so here and here and here and here and here, we're using the next X value on each row, but we're subtracting always the same number, always the mean. So if I put the mouse cursor over the bottom right-hand corner, drag this down, Excel repeated those calculations, and now as I scroll through these cells, if you look up here in the function bar, forgot to put in the $sign into my actual formula, not just the handwritten one. So I'm going to insert a $sign there. and repeat that process. There we go. So now as you scroll through and I select each one of these cells, if you look up here at the function bar, look at that first value right there. It says D8. Well, when I click on the first value in column F, you see F3 minus C13, and then F4 minus C13, and so on. The values they should be D's. What happened there? Let's change that to a D3. Nope, sorry, they're correct. Yeah, everything's good. D3 minus C13. There we go. Yeah, everything looks fine. So you see, the index on the D is changing, but the index on the C doesn't change. Okay, so that's what we want. All right, so now the second step, now that we have x minus x bar squared, we have to take each one of those numbers and multiply by f, the frequency. So that next column, let's just take column F, which is x minus x bar, quantity squared, and let's multiply that by the corresponding frequency. So we basically want to take this number here and this number here and multiply them. That'll be the x minus x bar squared multiplied by the frequency. So if we look over here at the formula, we're now working on this step, times f. All right, so let's say equals x minus x bar squared, which is right here. Multiply that by the frequency. And we have to do that 5 more times. So let's have Excel do that for us. Drag that down. And now the next step in the formula is add those numbers up. So now we want to look at the entire numerator and find the sum of each of those x minus x bar squared times f. So let's put that down here. And again, for the sum, let's make this a nice yellow. So in this cell, I'm going to have the sum of x minus x bar quantity squared times frequency. So that's the entire numerator of the fraction. Okay, so we'll add them up, use the sum function, equal SUM, parentheses, I only want to go up to G8. Okay, so now we have to take that number, divide it by n minus 1, and take the square root of that. Okay, so we just calculated this number here in yellow in column G, so that's G9. All right, so what we want to do is take G9, divide it by n minus 1. So we could just type in a 69, because n is 70, so we want to divide by n minus 1 or divide by 69. Okay, so that's that sum divided by n minus 1, but we also want to take the square root of that. SQRT. So that's the square root of the sum. Remember, G9 is that sum, so we take that sum divided by 69, and we want the square root of that. And so that is going to go right here in the estimated standard deviation. Because I'm just going to type in exactly what I just wrote on the screen, equal SQRT, parentheses, I'll select the G9 divided by 69. So now we've now executed the entire standard deviation formula. Now I want to do the same thing I did at the end of the first video, is now find the exact value of the standard deviation of the data set. So let me erase this. So now what we're going to do, see how close is our estimation. So we want to take the original data, find the standard deviation, and that's easy to do. That's just that's a 10-second process. When you're doing exact values in Excel, it's very quick, very streamlined. So it's just a one-step, one-line function. Equal stdev.s, and in parentheses the location of the data. All right, so over here next to exact standard deviation, let's say equal stdev, and then the dot s is because it's the sample standard deviation, and then in parentheses, I'll just use my mouse to select the data that I want to find the standard deviation of. And so that should give us the standard deviation, the exact value of the standard deviation of this data set. And I'm going to round this again to 4 decimal places. Remember, the rounding rule is to use one more decimal place than your original data. And again, our estimation is off by only, a few thousandths of a gram. So our estimated standard deviation, again, coming from none of the original data, just an estimation of each data value, gives us a standard deviation, just like in the case of the mean, with the standard deviation very close, very, very close to the exact value coming from the original data. So, just a quick overview of what we just did. And again, we did this in multiple steps because this is an estimation. We took the mean of the frequency distribution, found that first. Then we found the mean of the actual data, so the exact value, and we used equal average location of data to do that. And those two values, as you can see, very, very close. And then we repeated that process with the standard deviation. We first found the standard deviation of the frequency distribution here, and then we found the standard deviation of the data set itself, the exact value, using equal stdev.s, parentheses, location of data. And that does it. I mean, this was a long, sort of cumbersome process, again, because it was an estimation, no built-in function in Excel to do that, so we had to do it in stages. Hopefully it wasn't too much to see at once. All right, that is it for this video.